Okay, the next concept I want to discuss is the concept of limiting and excess reactant. And let's just look at an example with this. So we'll have 2SO2 plus O2 going to 2SO3. So we have this reaction taking place. Let's just assume we have some reactor and we just throw in the mix 3,000 moles SO2, 1,000 moles of O2, and we let this react, and we want to know how much SO3 we produced. And this is again where we can use our stoichiometric ratio to help us determine that. What we should realize is that one of these particular species is in excess, which means that after we've gone the full reaction, one species will be gone, one species will be left. And in this case, O2 is the limiting reactant, SO2 is the excess reactant. So if I just let this go to completion for the reaction, what will happen is I will be left with 0 moles of O2, and that's because that's the limiting reactant. But if I let all of the O2 react to form the final product, I'll produce 2,000 moles SO3. And again, I just use the stoichiometric ratio, which is 2 to 1. And then we will be left with 1,000 moles of SO2. And that's simply because you can look at here and say, okay, if I react all 1,000 moles of O2, I need 2,000 moles of SO2. And that's because of the stoichiometric ratio here. There's a 2 to 1 ratio. So if 1,000 moles of O2 react, I need 2,000 moles of SO2. But lo and behold, I have 3,000 moles. So I have an extra 1,000 moles of SO2. So let me give you a more mathematical way to determine the limiting and the excess reaction. So let's write out our equation again up here. 2SO2 plus O2 goes to 2SO3. And again, we'll assume we have 2,000 moles of SO2 and 3,000 moles of SO2 and then 1,000 moles of O2. And we want to again use our mathematics to determine what is the limiting and excess reactant. Well, we know the stoichiometric ratio is 1 mole of O2 reacted, 2 moles SO2 reacted. So that's just the stoichiometric ratio. So for every 1 mole O2 that we react, we have to have 2 moles of SO2. Well, if we take our ratio here of 1,000 moles of O2 for 3,000 moles SO2, that's basically 1/3. So it's 1/3 mole O2 per mole SO2. So what we do from here is we look at these numbers here. So 1 and 1 here, they match for the moles of O2, but the numbers on the bottom don't match. That's 2 and that's 3. This 3 is bigger than 2. And what that's telling us is that we have a lot more SO2, since this 3 is bigger than the 2, than we would need for the complete reaction. So in this case, SO2 is in excess. That's again 3 greater than 2. And then O2, the other species, limiting. On the other hand, if we were looking at this and the number on top was greater, say for instance I calculated this to be 2 here and 2 here for the moles of O2 to SO2, then this 2 would be greater than that 1, so that would mean O2 is in excess. So whichever number is bigger than the actual stoichiometric coefficient, that's how we determine whether something is an excess reactant or a limiting reactant. So let's look at how we quantify limiting and excess reactants. So 2SO2 plus O2 goes to 2SSO3. So that's our reaction right there. Let's put that up there. And we have this reaction, and again we're going to have 3,000 moles SO3, 2,000 moles of SO2, and then 1,000 moles of O2. Those are our two reactants. So we can quantify this using fractional excess. So we determine that SO2 is an excess, and the ratio, or the equation, is just the number of moles in the feed minus number of moles in the stoichiometric case over number of moles stoichiometric case. So based on the stoichiometric ratio, we would need 2,000 moles of SO2, so this number right here, the stoichiometric number of moles for SO2 would be 2,000, and this is what's fed into the reactor, in this case 3,000 moles. So if we just go ahead and use this equation, it is 3,000 minus 2,000 divided by 2,000 equals 1/2. And that's the stoichiometric, or the fractional excess of the species that's in excess, fractional excess. And then the percentage excess is just this number multiplied by 100. So since this is 1/2, that's 0.5, then that would just be 50%. So just multiply this number right here by 100, 50% excess. And so we may be given a problem oftentimes where we're told that we have this reaction and that a particular species is in excess. Maybe it's in 25% excess, or it's a fractional excess of 0.33, whatever. But we can use this equation to quantify what the actual number of moles we have in a particular problem. So just in summary, we need to remember that oftentimes when we have a reaction taking place, one species will be fully reacted or could potentially be fully reacted. That's the limiting reactant. And the other molecule, or multiple molecules, you may have multiple molecules or atoms in excess, those are the ones that if the reaction goes to completion, they still remain left over. Those are the excess species. And we can use our analysis of the amount of molecules and stoichiometric coefficients to determine which one is in excess and which is a limiting reactant. We can also quantify that using fractional excess or percentage excess. And there you have it.